We're going to start with this fill in the blank paragraph. Our goal today is something called rationalizing the denominator, and it means rewriting a denominator that is starting with a radical and rewriting it so it has no radicals in the denominator. And we talked about why in class, but I'm not going to as part of the video, so I can be sure to keep it short. But feel free to come in for tutoring or ask me in class, and I would be happy to explain it to you. In the cartoon above, Woodstock simplified the radical expression by rationalizing the denominator. This method may be used to remove radicals from the denominator of a fraction. Now you'll notice we have these two examples here that we're going to use to practice. These are really just to set us up for our actual goal problem, is to simplify these fractions that have radicals in the denominator. So for this first one, you'll notice I have a radical in the bottom of my fraction. To get rid of that radical, I am going to multiply square root of 3 times itself. Now this is going to give me 3, right? You'll see there's no more radical in the bottom, in the denominator. Now why this works is because you can think about this as the square root of 3 times 3, and for each pair you pull out 1, 3, and then there's nothing left in the radical, so it goes away and we have just 3. You can also think about it as the square root of 9, which is also just 3. And then whatever you multiply the denominator by, you have to also multiply the numerator. So that's going to give me the square root of 5 times 3. And I can't factor either of those anymore, and there's no pairs to simplify. So I'm just going to multiply those together and get 15. So what I have done is rewritten this fraction so that this, which was an irrational number, now I have a rational number. So I have rationalized the denominator. And then for number 2, we can start the same way. Multiply the denominator by itself and the numerator by that same thing, radical 12. So in the denominator, the radicals cancel, leaving me just 12. And in the numerator, what I have is the square root of 7 times 12. Now 7 can't be factored anymore, so I'm going to leave it alone. But 12 I can factor as 4 times 3. And the 4 is a perfect square, so if I can take the square root of that, I get 2. I bring it out front. Excuse me. And that is going to give me 2 square roots of 21 over 12. And then the last thing we have to do for this answer is simplify the 2 over 12. So I can divide 2 out of both of those. And that gives me square root of 21 over 6. Now for these bottom examples. All right, so before I talk about this paragraph, I'm going to show you something on number 3. And don't write this down. This is actually incorrect. I just want to show you something. If I were to just multiply this bottom by square root of 3, it wouldn't actually get rid of the radical, because after I distribute, I would still have a radical. I would have just transferred it over to the first term. So here's what we're going to do instead. We're going to multiply by something that's called the conjugate. So the conjugate is formed by keeping these terms the same and changing the problem from a subtraction problem to an addition problem. And whatever you do to the bottom, you also have to do to the top. So before I show you the math about that, let's fill in this paragraph. What happens when the denominator has two terms? We multiply by the conjugate. This will remove the radical from a binomial denominator. So binomial means it has two terms. The conjugate is when you keep the terms the same but change the middle sign. So we kept it the same, but we changed the middle sign. So in the numerator, that is going to be a distributed property. 4 times 4 is 16. 4 times radical 3 is positive 4 radical 3. Now in the numerator, I'm going to FOIL. The first terms are 4 times 4, which is 16. The outside terms are 4 times square root of 3, which is positive 4 square root of 3. The inside is minus 4 square root of 3. And the last terms are negative radical 3 times positive radical 3 is minus square root of 3 times square root of 3, just like we did up here, is 3. Now notice that the middle terms cancel out, and that leaves me 16 minus 3, which is 13. And you can't combine the terms in the numerator because they're not like terms. The 16 would need to have a radical 3 in order to combine it with the 4 radical 3. Now in class, we did a warm-up where we talked about multiplying conjugates and how you can do this shortcut method. When you multiply conjugates, the dropping of the middle terms, this canceling, will happen every time. So you could just skip it. So in order to get just this part and this part, what we do is square the first term, square the first term, 4 squared, and square the second term, and then subtract them. So that would be 16 minus 3, which is 13. And I'm going to do that shortcut on number 4. You don't have to do that shortcut. You can FOIL every time, and it will still work out the same. This is difference of squares. If you remember from our factoring unit, it's just going the opposite direction. It's already factored, and then we're just doing the difference of the two squares. So on this one, to set up my conjugate, I keep the terms the same. Radical 11, radical 6, and I changed from a subtraction problem to an addition problem. And whatever you do to the bottom, you also have to do to the top. So in the numerator, I distribute the 15. So that gives me 15 radical 11 plus 15 radical 6. And on the bottom, I'm going to do the shortcut, square the first term, square the second term, and subtract them. So that's going to give, so right here in the denominator, the square of a square root, those cancel, leaving me just 11. Same thing with the 6. The square of a square root is 6, and 11 minus 6 is 5. So my next step looks like this. And while this is good math, it can simplify one more time. All three of these terms have a 5 factor in common that I can divide out of them. So that becomes 3 radical 11 plus 3 radical 6. And in the denominator, 5 divided by 5 is 1, which I don't need to write. And just a word of caution, when you have multiple terms and you're trying to simplify a fraction, you either divide a 5 out of all 3 of these things or none of them. It can't just be like 2 of the things. It has to be all of them or none that you're simplifying.